I don't know, the presentation is visible?
Yes, it is visible.
Perfect. Sophie, thank you for inviting us and share with you our experience. So just a quick overview about AQUALE. AQUALE is an engineering company active in the field of hydrogeology, environmental protection, and renewable energy. With an extensive experience in the implementation of numerical hydrogeological models. And therefore, in general, we carry out the multi-tracer test in most cases to implement and enrich hydrogeological models. Also, in the list on the right, there are our main professional skills. So a quick geographical overview where the multi-tracer test was carried out. The industrial plant is located in central northern Italy, in the Tuscany region on the Tyrrhenian coast, where the chemical industry has been active for more than a century and involving the use of limestone for a nearby quarry. In the image below, the geographical location, and of course, a zoom extracted from the GIS of the industrial plant. So about geological and hydrogeological overview, the subsoil present below the industrial site and the surrounding areas consist of the following deposits from the oldest to the most recent. So we have Pleistocene deposits here in the yellow part, the Holocene alluvial deposits close to the river here in the rose, and the backfill soil in the zone of industrial plant. So in general, we have alternation of sandy, clayey, and gravelly deposits, mainly of carbonate origin. From more in detail, from a hydrogeological point of view, we have a presence of two aquifers. So a shallow aquifer to the west part of the site and two different aquifers in the eastern part, a shallow aquifer and a deeper aquifer. The shallow aquifer is present below the entire industrial area, limited potential and variable permeability, absence of continuous aquifer system due to a constant irregularity of the water flow, and the deep aquifer is present in the southern, in the eastern part of the site, so close to the river. And it is an heterogeneous system with good hydraulic properties developed in the gravelly and sandy formation of the riverbed, of course, and is protected by a clearly cover that provides this degree of artesianity. This is important to understand the context that we carried out our multi-tracer test. So the aim of the multi-tracer test is to investigate in detail the underground flow velocities for determination of the hydrodispersive parameters useful to the implementation of the hydrogeological transient model and also contaminant transport model. The tests were carried out in a complex industrial area, here indicated in the red zone, and also the presence of hydraulic confinement barrier along the southern western limits of the industrial site. This hydraulic barrier is managed by us in collaboration with the client, of course. The multi-tracer tests were developed in two different phases. The first phase involved two different injections. So the first injection in PZ-87 with 6 kilograms of uranium and an automatic monitoring with stream fluorometer were installed in PZ SOD 49 and PZ SOD 50. Here on the right, you can see more in detail the location of the piezometer. And the second injection in PZ SOD 85 with 6 kg of sulfur B, and an automatic monitoring with the stream flow meter was installed in PZ SOD 60. An important detail is that the arrows drawn in the background represent the main direction of the underground flow, just for information. This slide shows some different moments during the installation of the fluorometers to monitor the two different injections. So above, tracer monitoring installed in the PZ SOD 49, and below the tracer monitoring installed in SOD 50. An important information is that for safety reason, all fluorometers were installed inside the piezometer with a drive-over manhole, and as we can see, for example, in this image. Always about the first phase, at the end of March, we carried out a reorganization of the monitoring network due to a problem encountered on the SOD 87 well references, and we moved the fluorometers from SOD 50 to SOD 44. Here in the image we can see the rearrangement of the fluorometer. About the second phase, concerning only a single injection in the PZ SOD 43 with the 6 kg of urine, and we installed also an automatic monitoring with the stream fluorometer in PZ SOD 42. You can see that the distance from SOD 43 and SOD 42 is not so much. For the reason, another important information from a hydrogeological point of view is that from 11th of May, for a reason of tracer test duration and to be as efficient as possible from the point of view of tracer monitoring, once it was verified that the tracer had arrived and passed, of course, so we moved the fluorometer from SOD 42 to SOD 88 in the hydraulic barrier area to monitor if the tracer also arrived in the area, in the barrier area. Finally, the third phase involved purging and piezometer of the piezometer into which the tracer had been injected, and this activity with the aim of verifying whether the quantity of tracer was trapped around each of injection piezometer. So the purge activity consists in 5 hours purging with low flow pump for a total of 2 meter cube pumped from each of the injection piezometer. And here we can see that a quite quantity of tracer we purge from the piezometer. About result and consideration of this multi-tracer test. Regarding the injection of SOD 87, the monitoring in SOD 49 showed that tracer detected intermittently, indicating possible presence of differentiated preferential path, and therefore the presence of different effective porosities. Possible external interference, for example, undeclared pumping or residual leaks, odor, and another important element, a strong heterogeneity of the subsoil. About the monitoring made in SOD 44, the tracer was not detected. So in general, it is important to remember, of course, we did activity, the purging activity, as we mentioned it in the previous slides. And in general, it is important to remember that the tracer must recover it in 24 or in 48 hours are only estimated, and so is poorly indicative. And in this case, in this specific case, the concentration of the sample remained quite high even after 5 hours of purge. So the estimation of the mass recovered in 24 and 48 hours probably is less precise. Here in this slide, using a track software, a back-through curve analysis was performed. In fact, no clear evidence of a single curve, but some arrival of a discontinuous trace. So the hypothesis of a sum of curves with different hydrodispersivity characteristics, thus providing different range of parameters, and the parameters are indicated in the list in the right column. So about the second injection in the SOD 85, the monitoring in SOD 60 showed that a possible tracer detected, but very disturbed measurement. So due to possible alteration to pumping or residual leaks or hydrochemical variation, we don't know exactly. Another hypothesis is that we have a very high transit speed for lithologies present in the subsoil, and connected to a possible presence of preferential flow, for example, underground pipeline. Also in this case, even more than the first injection, the mass of the tracer recovered in 24 hours and in 48 hours is really fully estimated and indicative. And in this specific case, it was not possible to make a back-through curve analysis. Regarding the third injection in SOD 43, the first monitoring, so in SOD 42, showed a very clear arrival of the tracer and a very good back-through curve was detected. For concerning the second monitoring in SOD 88, didn't show a direct evidence regarding the presence of tracer. So using also in the first injection, using a track software, back-through curve analysis was performed, of course, and we obtain an excellent breakthrough curve from which it was possible to extrapolate much more reliable hydrodispersing parameter. And those data was very important to implement the transient model. So, which is the follow-up activities? The multi-tracer tests were necessary for the acquisition of hydrodispersive parameters and to characterize the migration time of the underground water flow in context of the continuous updating of the transient model and, of course, the subsequent implementation of the transport model of contaminant. Our modeling activity is still in progress. Thank you.
Okay, thank you very much, Marco. So again, as with the previous presentations, don't hesitate to ask questions in the chat or by raising your hand in reactions.
Of course, our presentation is, I think, more practical. It's really a real situation that we have in industrial site that we work. So.
Will this project be ongoing, or is the client happy with the current results?
No, it's still ongoing. Yeah, sure. Because the model, the transient model, now is in developing also in the other part of the industrial plant. Yes. And of course, these multi-tracer tests are very, very important to collect all the hydrodispersive parameters to implement the transport to hydrogeological model.
I have a question about, because you changed the site of the injection in the second phase. Yeah. How do you avoid that tracer from the first injection could still arrive at during the second injection?
The problem were that we detect this problem of the references of the piezometer only after the start of the tracer test. So if we estimate that the tracer test could be arrived also in this part, we arrange the fluorometer. We activate the fluorometer also for the other tracer, not only for the uranin, but also for the sulfo B. And this for that reason that we had to rearrange our test during the realization.
Okay. So this is a clear example why you need a multi-tracer test as well. Otherwise, you would have interference.
Exactly. Yes. Exactly.
Any other questions from the participants? There don't seem to be any more questions. Is it okay if I share your email address?
Yes, of course.
Or at least the address that the info.
Yeah, no. It's my personal address or info. It's the same. Yeah, no.
Okay.
No.
Well, thank you very much, Marco.
Thank you too, Sophie.
I think now it's time for our last speaker of the day. Rafael, maybe you can start sharing your presentation.
Yes, Sophie. I will share now. Can you see my screen?
We see your screen perfectly.
Yes. Thank you, Sophie and Traqua, for inviting for this webinar. Firstly, I'm sorry for my English. I'm studying the English, making classes. And now I will present my work, the fluorescent tracers applied in dams. Okay, I'm talking from Belo Horizonte, Brazil. Belo Horizonte is the mining capital of Brazil, and we have a lot of dams, tailing dams, and this technique is important to characterization of these dams. Okay, and this research was motivated by the Mariana disaster, when the Fundão dams, the ruptures of those dams that affected the Doce River here in Brazil. So they conducted research about the development of tracers techniques applied to dams. Okay, this research was finished last year and was performed at the CDTN, the Center of the Development of Nuclear Technology here in Brazil. Okay, and why use tracers in dams? We need other techniques for dams studies. the traditional techniques is not able to access all the information of water flux in dams. Okay, então we need to understand this flux in dams, and other techniques cannot access the traces results. Okay, and we do bibliographic research about tracers, and now we are looking for a mining company that have interest to study dams using fluorescent tracers. And we need that the geotechnical engineers know these techniques. Okay, então, so here the tracers that we study. We study environmental tracers like isotopes and physical-chemical parameters and pollutants too, and some artificial tracers like isotopes and fluorescents and salts too. Okay, and we will talk about the fluorescent dyes. So in dams, water flux is one of the causes of the failure of these dams. The flux in the ground, okay, the flux between the natural terrain and the dams, and this flux can cause the erosion, the internal erosion, the piping, and tracers can be used to promote this understanding of water flux in dams. So is an important technique. Okay. Here are some references books. These books written by Bedmar and Araguas, Detection and Prevention of Leaks from Dams. This book is from the International Energy Agency, okay, and these books have a lot of techniques like tracers to detect these leaks in dams. And we have other books to isotopes and tracers in general, okay? And we use the labeled goods approach, the systems, okay? We have the entrance of the tracers, like environmental and artificial tracers, and the dam system process these tracers, and downstream we sample and detect these tracers to know more about the system. Okay, this is the approach we use. In the dams, we have a scenario of mixing waters. Okay, here we can see in downstream view, we have groundwater, aquifer groundwater, and we have the water from reservoir. And this is a zone of mixing of these different waters from reservoir and from aquifer, and the tracer can be used to increase the understanding of this mixing zone. The investigation techniques. First, we need to have a data collection, geological data, and geotechnical, hydrogeological, environmental, hydrochemistry is the first step of these studies. And we use environmental traces like hydrochemistry, isotopes, and after this point, we use the artificial tracers. We chose what's the more applicable tracers. We define the injection and sampling points. We have estimation of test duration. Important to communicate with the community and execute on protest and the text. Okay, and we have complementary techniques like geophysical, logging, geoelectrical techniques, hydrogeological modeling like mud flow, free flow, for example, hydrochemical modeling like speciation modeling and mineral saturation, hydrometry, flows and water levels in dam sites, and multivariate statistics to analyze the environmental tracers. Okay, is important before this step to characterization. The site is important to characterization of the site. So fluorescent dyes can be used in the displays. Now we have some limitation of this fluorescent. So it's important to access the water quality because acid water can react with the tracers. We have here a lot of tailings dams from gold mines. Is common the water, the acid drainage. Okay, so here a photo from the Bordo Seco in Venezuela. The authors Contreras and Hernandez suspected that a leaks near from left abutment have origin in the reservoir water. Okay, so they perform a tracer test to understand the interconnections, the water velocity, and groundwater parameters. Okay, they confirmed the interconnection through this water and the water leaks and left abutment of this dam. Okay. Here in this picture, we can see 3 hydraulic connection tests. We can inject the tracers in the reservoir water and sampling or detecting in monitoring wells. Okay. Inside the dams or downstream the dam. Or we can inject in a monitoring well and detecting the tracer in downstreams others monitoring wells and in the tool of the bottom drain of this dam. Or in other case, we can inject the tracer in the bottom of a reservoir in the case of dams for the stored water, or in dams for hydroelectricity. So in this case, tailings dams is not it's difficult to inject the tracer in the bottom of a reservoir. We inject this tracer to analyze the flow water in the foundation of this dam, okay, and detect in the wells in foundation and in the bottom drain, okay. Three kinds of the hydraulic interconnection tests. Other tests we can be used in dams is the single well test. We can inject a tracer inside the well and mark using a hose and mark the water column of inside the well. So with the water flux across the well have a great velocity, we have a great dissolution of this tracer. And if we have a slow water velocity, we don't have dissolution of this tracer. Okay, here a picture example of this case. We inject the tracer and have a detection of the tracer with a fluorometer can be used to this. Okay, and we conduct the detection in a time like five times in the time, okay, and to see what zones have more water flux, like this in these studies conducted by Diaz in Chile in tailings dams. Okay, Diaz used a radioactive tracer, but can be used a fluorescent tracer too. Okay, and they use it in a single well test, and this is the result of Diaz experiments, and they can see the more velocity in this part of the well and interconnection parts of the flux inside the well here. So it is useful to calculate the water velocity inside the well, and can be and this velocity will be used to determine the velocity inside the screens inside the dams. Okay. Here, other experiment we conducted here in Brazil in a small dam in a farm, and we calculated the flow rates in the spillway of these dams. We conducted combined fluorescent dyes, here fluorescent, and salt, sodium chloride, and here the breaking through curve of these tests, okay, of the plume of the tracer, and so we can calculate the flow rate using the fluorescent tracer. And the fluorescent tracer or other tracer, artificial tracer, can be used to definition of possible areas of water leaks in these dams, to define water points of leaks in these dams, can use it to promote it as cement injection, the grouting in a specific place, not in all parts of the dam, and after the grouting, the verification of efficiency of this grouting, if if this cause an impermeable curtain, okay? These are objectives. Bringing an economy, great economy, and more safety in the dams. Here some conclusions. These studies with using tracer technology allow early detection of leaks and internal erosions, definition of hydraulic connections inside the dams and in the natural terrain, and determination of groundwater velocity and some hydrogeological parameters, definition of the place of the grid tests permeability, better understand of the transport of the contaminants, calibration numerical models, the numerical models, and contribution to a better management of these dams, to a better decisions, to reducing risks of the companies of these ruptures. I'm sorry, I can. Now we are looking for a mining company interested in carry out a study using fluorescent tracers. We have some difficulties to search this company. The geotechnical engineers don't know about this technique, and we need, with this technique, can be more disseminated and to knowledge of the geotechnical engineers. So I thank you, Traqua, and our audience to hear me and our work. Here are my contacts. Thank you very much.
Thank you very much, Rafael. We already have a question from another speaker we had today, from Pierre. He asks if you also observe vertical water fluxes within the tested wells, and how do you take into account in the interpretation of your horizontal groundwater velocity estimates?
Yes, the DIAs observe this vertical flux. I can share it again, the picture, and the DIAs, detect this vertical flux inside, and this interpret with this graphic. Okay, in this part of the graph, the concentration is decreasing in the time, and in the bottom of the well, the concentration increased, and the interpretation of this is the tracer was located in this part, move to down of the well, and here in the down, the tracer decreased the concentration in the time. It was the interpretation of this author.
Okay, I hope this answered your question, Pierre. I have a question myself. You say you want to disseminate this technology among dam managers. I assume it's because they don't frequently use this technology right now. What are dam managers using then at the current moment to detect leaks or other problems with dams?
Okay, the managers and the engineers using natural tracers is common here in Brazil, and it's very common to using water modeling, computational modeling, numerical modeling to modeling the water flux. But we are talking with these managers, some companies like Vale, for example, to disseminate these techniques to the geotechnical engineers. I have some students. I am a professor, and I'm talking about these techniques. These students will be the future of these geotechnicals here, and they concluded the importance of these techniques in the investigation of dams. But we have some problems. The companies have some fear about the studies. One fear is the contamination. They think that the traces can be contaminate the groundwater. Is difficult to prove that is not correct, this thinking. And other problem, we don't have today a legislation, legal resolutions about this technique. Okay, então, so this is a problem about to use tracers, intentional artificial tracers in the dams here in Brazil.
Well, thank you very much. Are there any other questions for Rafael? Don't hesitate to ask them in the chat. Is it? I don't have your Nova Terra email address though to share in the chat. Maybe if people have additional questions, they can ask you later.
Okay, I will share my email. Thank you for the opportunity.
I also want to take this opportunity to thank again all presenters, also from my colleague Gamal. It's really a pleasure to see this technology being used in all kinds of settings, also settings that we are not directly familiar with. So thank you for your presentations. And also thank you very much for all the participants. It was a pleasure to see that there is an interest for this quite niche technology, let's say. So the presentation was recorded. We will share it on our YouTube page, and also some of the presenters will probably share the presentation on their platforms. I'm just waiting for the confirmation of one of the speakers before sharing it. But once it's available online, I will keep you informed, of course, via email. So thank you very much, and have a pleasant either noon for some of our speakers or a very pleasant late afternoon.